Hello everyone, welcome to my channel. My name is Sanjeev Garg. Today we are going to discuss about the Fibonacci series and how we can efficiently calculate it using the dynamic programming. If you ever wonder or find problem while optimizing your solution, then this video is for you. So let's get started with Fibonacci series. So what the Fibonacci series is? Fibonacci series that starts with a two number. So Fibonacci series that starts with the two number, first number is 0 and another number is 1. So if I'll say Fibonacci of 0, Fibonacci of 0 is 0, Fibonacci of 1 is 1. Okay, now its subsequent number is the sum of its previous two numbers. So Fibonacci of, if I say Fibonacci of 2 is Fibonacci of 0 plus Fibonacci of 1. So it will become 0 and 1 is 1, that will become 1. Similarly Fibonacci of 3 will be Fibonacci of 2 plus Fibonacci of 1, that is become Fibonacci of 2 is 1 plus Fibonacci of 1 is 1, that will become 2 only, so it will become 2. Similarly for Fibonacci of 4 we can find Fibonacci of 3 plus Fibonacci of 2, so it will be Fibonacci of 3 plus 2 will be 2 plus 1, that is 3. So in this way we can calculate its subsequent number, which is the sum of its previous two numbers. So if we see this Fibonacci series in the hierarchy format, so how can we do that? Let's say I want to calculate the Fibonacci of 4. So Fibonacci of 4 will be Fibonacci of 3 plus Fibonacci of 2. Fibonacci of 3 will be Fibonacci of 2 plus Fibonacci of 1. Fibonacci of 2 will be Fibonacci of 1 and Fibonacci of 0. Fibonacci of 2 will be Fibonacci of 1 and Fibonacci of 0. Similarly, okay, all these we have already calculated. Fibonacci of 0, we know Fibonacci of 0 is, okay, let's, Fibonacci of 0 is 0, Fibonacci of 1 is 1, 0 plus 1 is 1, Fibonacci of 1 is 1, 1, and this one is 0. 1 plus 0 is 1, and this is 1 plus 1 is 2, 2 plus 1 is 3. So in this way we are calculating the Fibonacci numbers. If you see, to calculate the Fibonacci of 4, we have to calculate Fibonacci of 3 and Fibonacci of 2. Fibonacci of 3 we have to calculate Fibonacci of 2 and Fibonacci of 1. To calculate Fibonacci of 2 we have to calculate Fibonacci of 1 and the Fibonacci of 0. So if you see, we are going from here top to down, okay. So, and one more thing you also see, to calculate Fibonacci of 4 we have to calculate Fibonacci of 3 and Fibonacci of 2. So these are the two numbers here. So if you see, here we are calculating only Fibonacci of 4, here we are calculating two numbers, Fibonacci of 3 and Fibonacci of 2. Here we are calculating four numbers, Fibonacci of 2, Fibonacci of 2 we are calculating, Fibonacci of 1 we are calculating, Fibonacci of 1 we are calculating, Fibonacci of 0 we are calculating. So these are four numbers. Similarly in the worst case it will come here is 8. So if you see, every node has the two child. So I can write this one as 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, similarly 2 raised to power 3 up to 2 raised to power n. So if you see, this will become, okay, so this will become 2 raised to power 0 plus 2 raised to power 1 plus 2 raised to power 2 plus 2 raised to power 3 up to 2 raised to power n. This is in a GP series and we already know that the value of this is 2 raised to power n. So time complexity will be order of n. So time complexity will be order of n only. Time complexity will be 2 raised to power n, 2 raised to power n, This is exponential time complexity that we are calculating here. Okay, so if I'll talk about the space complexity here. Space complexity, if I'll talk about the space complexity here, so first one is, if you see, in every, okay, so we are going to the exponential, every function we have to calculate. Okay, in the stacks, what we are doing, to first we are calculating the f of 4. To calculate the f of 4, we need f of 3 and f of 2. Okay, to calculate the f of 2, we need f of 1 and we need f of 0. Once this is calculated, this is calculated, then f of 2 is calculated. Now in the stack, to calculate the f of 3, we have calculated already f of 2. Now again we will calculate f of 1. Okay, so if f of 1 is also calculated, then f of 3 is calculated. Similarly, what we are doing, every node we are putting into the stack. So here the time complexity is 2 raised to power n, and the space complexity is order of 2 raised to power n only. So we are taking that much of the stack space. Okay, stack space. Okay, so to calculate the Fibonacci series. Okay, if you see, there is one problem, or I can say there are some sub problems that we have already solved. If you see, okay, if you see, this is f of 1 here. Okay, f of 1 here is also here, f of 1 is also here, f of 0 is here, f of 0 is here. Okay, now if you see, there are problems that we have already calculated, so there is no need to recalculate it again and again. So what we can do, we can store this value in some variable or some in array, so that we can reuse them and we do not have to calculate it again and again. So now let's do again this graph. Okay, so this tree, f of Fibonacci of f of 4 will be Fibonacci of f of 3, Fibonacci of f of 3, and Fibonacci of f of 2, and Fibonacci of f of 3 will be Fibonacci of 2 and Fibonacci of 1. Okay, f of 2 will be f of Fibonacci of 1 and Fibonacci of 0. So we have already calculated the Fibonacci of 1, let's say, and Fibonacci of 0. Fibonacci of 0 is 0, Fibonacci of 1 is 1. Now Fibonacci of 2 will be 1 and 0, that will be 1. So now we have already calculated Fibonacci of 1, Fibonacci of 1, and this one is already calculated, 1 and 1 will be 2, Fibonacci of 3 will be 2. Similarly, Fibonacci of 2, we do not have to calculate it again, we have already stored it as it is 1. Now 2 plus 1 is 3. So in this way we can calculate the Fibonacci numbers by storing the value. What we are doing, we are storing in somewhere that Fibonacci of 0, Fibonacci of 1, Fibonacci of 2, Fibonacci of 3. Okay, so we are storing these numbers basically. So Fibonacci of 0 we have already stored 1, Fibonacci of 1 we have already stored 1, 0, and Fibonacci of 1 we have already stored, that is 1. Now to calculate the Fibonacci of 2, we need two number, Fibonacci of 0 and the Fibonacci of 1. So we will calculate the 0 plus 1, that is 1, and we are going to store it in the Fibonacci of 2. So again, let's say if this Fibonacci of 2 again will come, we will not recalculate it, we will pick from this array. So if you see, in this worst case, we are calculating each number a single time, each number a single time. If we have to calculate for Fibonacci of 4, we have to calculate Fibonacci of 3, we have to calculate Fibonacci of 2, we have to calculate Fibonacci of 1 and Fibonacci of 0. So if I have 4 number, I need 4 operations. Similarly, if I have to calculate Fibonacci of n, we need n numbers, n nodes, or n time of the functions to run. So if you see, it will take time complexity is order of n only. Earlier it was 2 raised to power n, that was the exponential. Now talk about the space complexity. Similarly, in the stack space, we are calculating Fibonacci of 4, Fibonacci of 3, Fibonacci of 2, Fibonacci of 1 and Fibonacci of 0 only. Only n operations or n functions only, n functions only. So it will be order of n only, order of n only. So here the time complexity will be order of n, and space complexity is order of n only. So what we are doing here, we are storing the value here, we are storing the value here. This is called memoization. Memoization. How we did memoization? If we have overlapping sub problem that we have identified here, f of 2 is here, f of 2 is here, f of 1 is here, f of 1 is here. If we have overlapping sub problem, then we can easily store in a array or in any other variable, so that we can use the dynamic programming. So now we saved our time and the space complexity as well. Now if you see in the space complexity, we have taken this as a, this is a stack space, basically stack space. Okay, also we are storing this value in an array, as I already told you, we are storing this is the array. Okay, this is the array. So in the first case, we will have to take order of n order of n for array. So space complexity will be order of n plus order of n, that will be 2 order of n. So that will be approx to order of n only. So this is the space complexity. So can we reduce this? Okay, now let's if you see what we are doing here, we are storing these value in an array. Okay, and we are going from the top to down approach, top to down approach. Now let's try, and we are using basically recursion here. So if this is my array, okay, if this is my array, okay, I know Fibonacci of 0 is 0, Fibonacci of 1 is 1. I also know that its subsequent number is the sum of its previous two numbers. So next number will be 0 plus 1, that will be 1. Next is 1 plus 1, that is 2. Next is 2 plus 1, that is 3. Next is 3 plus 2, that is 5. Next is 5 plus 3, that is 8. Similarly 13. In this way we are going to calculate. So if I go from the down to top, then we can easily calculate it without recursion. So we can optimize this, we can optimize the space here. So in this case we are not doing any recursion now, so we can use only array space. So array space. So what we will do, we will let's say we have this array, we already know the first two numbers, that is Fibonacci of 0 and Fibonacci of 1. Now Fibonacci of 2 will be sum of this number and this number. This is 0 plus 1, that will be 1. Now this plus this is 1 plus 1 2. Now we are not using the stack space, we are just simply iterating. So this is iterating, and this is iterating, we are iterating, so no stack space is required. So here the time complexity will be, because we have to fill this array, so definitely the time complexity will remain same, order of n, but the space complexity is order of n only for array. Okay, for array space complexity will be for array. This method, this approach is basically we call is tabulation approach. Okay, so now we have discussed, one is first approach, in which we are going in all the directions and find out the solution for each of the Fibonacci numbers. After that we discuss the memoization approach, in which we are solving the sub problems, overlapping sub problems by the memoization, by storing in the array. Now third one is the tabulation approach, in which we are going from the bottom to top, in which we are not using recursion, we are simply just iterating. So in this way we have saved this order of n. Now we have one thing, observe here, can we reduce this space? Can we reduce this space to order of 1? Can we do this? Let's see this. Okay, we know that Fibonacci series is subsequent number is sum of its previous number, sum of its previous two number. Okay, so if I have to calculate Fibonacci of 3, then I need Fibonacci of 2 plus Fibonacci of 1 only. So we need only two numbers. So in this, if you see, we are storing in an array. Instead of storing in the array, let's store in the two previous number. Let's say there is two variable, previous one and the previous two. Let's store there. Let's do this and try to run this. Okay, so we know our first number is 0, another is 1. Fibonacci of 0 is 0, Fibonacci of 1 is 1. Now we have to calculate Fibonacci of 2. Fibonacci of 2 will be, let's say this is previous one, this is previous 2 number. We are giving this is in a variable name. Okay, so Fibonacci of 2 we need is, what we are doing, it's sum of previous two number, 0 and 1. 0 and 1, that is 0 plus 1, that will become 1. Now it's good, now 1 will become here. So now Fibonacci of 3, how we will calculate it? Fibonacci of 3 will come here, so it will be the sum of its previous two numbers, sum of this number and sum of this number. How we will do this? If we see, what we will do, we will move from previous 2 here to previous 2 here, and previous 1 here to previous 1 here. So now this will be 1 plus 1 will become 2. Similarly for Fibonacci of 4, we need Fibonacci of 3 and plus Fibonacci of 2. So how we will do this? This will come here, so 1 plus 1 2 is here, this will come here, this is the sum of this one and this one. So this, what we will do, we will move previous 1 here and previous 2 here, so it will be 2 plus 1, that is 3 only. So to calculate any Fibonacci number, we need just two variables. So one variable is order of 1 only, another is order of 1 only. So total space, now we are taking order of 1 only, and anyhow we have to calculate the Fibonacci of n number, and for this we have to calculate Fibonacci of 0 1 2 3 up to n. So time complexity will remain same, time complexity will be order of n only. Space complexity will be now will be order of 1 only. So this is the way that the how time complexity we can reduce or optimize. Okay, so I hope you have cleared the example. So we have calculated, and so yes, yeah, let's start with the coding, how we can solve this with the coding. Basically how we can do this, let's start. Okay, so in this, if you see Fibonacci number, the Fibonacci number is commonly, let's read the example for, question first. Fibonacci number commonly denote for the sequence called the Fibonacci sequence such that each number is the sum of two preceding one. As I already told, each number is the sum of previous two numbers starting with the 0 and the 1. Fibonacci of 0 is 0, Fibonacci of 1 is 1. So Fibonacci of n is equal to Fibonacci of n minus 1 plus Fibonacci of n minus 2. Now just do that we did. Okay, so what we will do, first let's go with the recursion formula. Now just make a habit to make a util function for this one, util. Okay, util function is just to help in case we need to call the function internally or something like. Just have a standard this to write in the this format. Okay, we note that Fibonacci of 0 is 0, Fibonacci of 1 is 1. So let's say if our n is double equal to 0, then simply return 0. If n is double equal to 1, simply return 1. Okay, we can also write this to write in the 1, let's say in 1 1 if only if n is, I can say if n is less than equal to 1. If n is less than equal to 1, simply we have to return n only. Okay, because if n is 0 we are returning 0, if n is 1 we are returning 1. Else we are doing, what we are doing, we have to return, as what we have to calculate Fibonacci of, let's say we have to calculate Fibonacci of 3. Fibonacci of 3 will be Fibonacci of, that is 2 plus Fibonacci of 1 means n minus 2. Okay, now we have to return this, return. Okay, now let's remove extra line, just return this function from main actual function, return Fibonacci of util and Fibonacci of n only. Okay, let's run this. Okay, yes, can we submit this? Oh, okay, yeah, we are able to submit this. And yeah, this is the approach that we can use, but this is a recursion. As I already told you, it will take 2 raised to power n time complexity and the space complexity. So let's do it with the help of tabulation. In the tabulation, what we said, we will use a array. Let's say we have a dp array. Let's take an array equal to new int. Okay, so to calculate the Fibonacci of 3, we need Fibonacci of 0, 1, 2, and we are calculating 3. So we are taking one extra element. So we will take the dp size of n plus 1, and we simply will pass the dp here. Simply we will pass the int dp here. Okay, and in the same we will pass the dp here. We will pass dp here. Okay, so if you see, if n is less than equal to 1, return n, it's okay. Now before calculating, let's say we know already, know if Fibonacci of 0 we already know, Fibonacci of 1 is already know, Fibonacci of 3 we don't know. So first we have to check if we have already calculated this one or not. If dp of n is not equal to, let's say, minus 1, how minus 1, but we will simply return dp of n. Else we have to return this one. Else we have to calculate the dp. Let's say if dp of 3 is already calculated, we will return from here. If it is not calculated, first we will calculate it and we will store dp of n. Okay, we will store here. And now for the minus 1, what we have to do, initially we will fill arrays dot fill our dp with minus 1. Okay, it will simply fill minus 1 to our array. Now let's run this. Will it run? Let's see this. Okay, good. Okay, so this is the memoization form, how we can use this dp array. If you see, we have used this dp array, it will taking order of n, and if you see, this is the recursion, this is also taking order of n extra time for space complexity. So now we have to remove this recursion. How we can do this? We just have to use this array. So what we will do, we will pass dp here. We do not want this basically recursion. So what we will do, we have dp of 0, we already know dp of 0. We already know dp of 1, that is 1 only. Okay, so now we have to calculate dp for int I equal to 2, I is less than equal to n, and I plus plus. So now we have to calculate dp from 2 to n. So we will calculate dp of, now I will be dp of, let's say dp of 3 will be dp of 2 and plus dp of 1. So it will be dp of I minus 1 plus dp of I minus 2. Okay, got it. Now we will calculate dp of I is equal to dp of I minus 1 plus dp of I minus 2. So simply now we will return dp of n only, dp of n only, dp of n only. Okay, how we will return this? Let's run this. Okay, so this 4 will not come here. Int I is equal to 2, I is less than equal to n, I plus plus dp of I is equal to dp of I minus 1 plus dp of I minus 2, and we are returning dp of n. Okay, got it. Okay, now we don't need this array, we can remove this one as well. Let's run this. For int I is equal to I is less than equal to n, I plus plus, what is the problem here? If you see, okay, we are calculating from 0 to 1. Okay, so we have taken this array dp, sorry, we are what we are doing, we are just removing the recursion. So we need dp of, we need the array dp is equal to new int n plus 1, n plus 1. Okay, we need this array. Okay, so dp of 0 int I is equal to 2, from 2 to n we are going, and this semicolon will come here. Let's run this. Okay, it's good now. Okay, now we are able to submit this. If you see, we have removed recursion. Yeah, function is there, but we have removed recursion. We are not calling it again and again. We are just running this loop, and so that's the time complexity order of n. We are not using recursion, we are just using this dp array, so space complexity will also be order of n only. Now can we reduce this space complexity? Yes, we can reduce. I have already told you, instead of taking this dpn array, let's remove this array, let's remove from here. Okay, now let's remove from here as well, let's remove from here as well, let's remove from here as well. Okay, we need to take the 2 int previous one, as we are not taking dp, so let's say previous one, and this one is previous 2, int previous 2. So if you see, now what we have to do, we have to calculate the Fibonacci series. So let's take result is a variable as well to store the result. Okay, so our result will be previous 1 plus previous 2. As I told you, result will be previous 1 and previous 2. Now previous 1 become previous 2, and previous 2 will become our result. Okay, so instead of returning dp of n, let's simply return result. Okay, so okay, good, let's try to run it. Compile time error, yeah, it's good. Okay, we forgot to write this here. Yeah, good. Yes, very good. So in this way we have already taken these 3 variable, and this is nothing but order of 3, means just a constant only. So we have saved this space as well here. So this is the way how from the recursive solution, time complexity 2 raised to power n, we reduce from order n, and again order of n in this case as well, but in the space complexity we have reduced a lot here, so by using the dynamic programming. So that's all today for the dynamic programming for this Fibonacci series. Next question will be the same follow-up question for the Fibonacci series. I'll come back to you. Okay, if you like my video, Please do subscribe, do comment on my channel if you like this, so that I can make more videos for you. Thank you guys, thank you, bye.